I'd like you to look on page 61, the centre of gravity. This is revision from last year, so we're just going to go over it very quickly. So turn to page 61 in your workbooks. Here we've got some different shaped people. And question 1 is, when we're standing in the anatomical position, where is our centre of gravity located? And I want you to have a look at these people and make a decision where it's, in what region of the body is your centre of gravity located. Just write that answer in your book. Question 2, the centre of gravity is approximately 57% of standard height in men, and in women it's 55%. Why is the centre of gravity lower in women than in men? Again, take a look at these pictures and make a decision. I'll give you a big hint because you can see that the woman has more mass around her hips and thighs than the man. The man is much smaller. So that would be your answer there. Here you can see a picture of Tom Abercrombie shooting a basketball in a breakers game, and alongside him is a woman doing a balancing act. And the question is, would a higher centre of gravity in men and a lower centre of gravity in women give them any advantages in sport? So in men, a higher centre of gravity makes it easier for them to jump higher as less force is needed to raise the centre of gravity. And in women, the lower centre of gravity makes it easier for women to do balancing and stability activities. Could you fill that into question 3? Fill in the answer for question 3. So in men, the higher centre of gravity makes jumping easier since less force is needed to raise the centre of gravity higher. And in women, the lower centre of gravity makes balance and stability activities easier. At the top of page 61, there's a little activity there for you to try at home. Kneel on the floor with your feet flat under you, with your elbows flat on the floor, touching your knees. Just do as the book says there, and then answering the question, at the top, from the top of the page, explain why most women can and most women cannot complete that task successfully. What would be the reason why women are able to do it more easily than men? Think about it and write in an answer to it. You might like to give this activity a go at home with your family. And of course you can tell them afterwards that you know why you can do it better than them. It's because you have a lower centre of gravity, which means you can more easily counterbalance the mass of the upper body as it bends over to touch the coin. Over the page now in question 5, on the pictures in your book, you're to mark where the centre of gravity moves as they alter their body position. Generally, in the human body, as body parts move up and down or away from the body, the centre of gravity tends to move with it, and it's important that you understand that concept. Sometimes the centre of gravity can actually fall outside the body as well. It just depends on what position we put our body into. So here we've got on our first picture here, we've got the girl. You're to draw the centre of gravity, and of course it'll be just right round her hips there. Can I get my mark big enough? Just there. And then as she raises her arms upwards, see the arms have gone up, and of course the centre of gravity also will go up. So let me see if I can just draw it up a little bit. Yep, there we are. We've got the centre of gravity just up a little bit from where it was before. In the next diagram, The centre of gravity has moved that way, whoops, and is just on the edge there at the point of that arrow. And this last picture, where we see the centre of gravity has been lowered, so it's just at the top of her shirt there. She's lowered her centre of gravity, it's gone downwards. Whoopsie, that's too big. I'll see what I can do to undo that. So you can see she's lowered her centre of gravity, and it's also moved forward. So her centre of gravity has moved with her. So you mark those in on your diagram. Question 6. You're asked to locate the centre of gravity on the high jumper. You may recall from last year learning to find a centre of gravity from a person in an unusual position. So I'll just run through it here with you. You draw a square around the outside edges of the athlete. And you take lines through the middle, corner to corner, and that's approximately where the centre of gravity will be there. So that's where I'll change the colour of the mark. There we are, blue. That's the centre of gravity. So your answer here is that the centre of gravity is located outside the body and below the bar. This is because of the curve of the body and how much is above and how much is below the bar. In question 7, the Fosbury flop technique above gives the athlete a chance to jump higher than any other technique. Using that information, explain why this is the case. So I want you to have a look at it and realise that to jump over the bar, they actually don't have to get their centre of gravity over the bar at all. All right, they don't need to raise their centre of gravity over the bar. It actually travels under the bar. This means a greater input of force can give greater height jumped. So with your force, you can jump higher and go over something if you use the Fosbury flop rather than any other method. So just write in your books that they do not need to raise the centre of gravity over the bar as it travels under the bar. We're just going to briefly look at axes of rotation. Movements involving rotation can also occur around or through your centre of gravity, and they're known as axes of rotation. And you can see the axis of rotation is illustrated in yellow in your picture below, in your book. So to complete the table, the first demonstration is of longitudinal axis of rotation, and the example is twisting and diving or a pirouette in dance. The second one is a transverse rotation, and here we've got a forward roll for an example, or a forward or backward somersault. The axes of rotation always travel through the centre of gravity. And then the final one we're going to look at today is sagittal axis of rotation, and that is where you do a cartwheel or the bowling action in cricket. So the sagittal goes right through an imaginary line right through your middle, and you rotate around that centre of gravity. Complete that in your workbooks, and if you've got any questions about it, you can ask me in class tomorrow.